Okay, this is review for your practice test. The first 4 questions on this page all deal with the same equation. You've got to solve it in 4 different ways, and one of them you're not really going to solve by graphing because you're not going to use a graphing calculator. We'll start doing that in Chapter 8, but what you're going to do is you're just going to graph the equation. So let's start with this, and for the first one, it says we have to factor it. So I'm going to scan it. The first thing I'm going to look at is it's got to have a 0 on one side and everything else on the other. So yeah, that's a 0, so that's good. Then I'm going to see what kind of factoring I'm going to use. Because it has this middle term here, I'm not going to be able to use difference of squares. So it's going to be a basic kind of factoring thing. If I can factor any common factor out, I will. I can't, so I'm stuck with this coefficient of 4 in front of the n squared. So that means I'm going to have to use AC middle. So AC is equal to a negative 20. The middle is equal to a negative 8. So the two numbers that would multiply to the negative 20, add to the 8, would be a negative 10 and a positive 2. So I have a negative 10. Positive 2, so those would have to have n's on them. I'll pull the negative 8n out and replace it by the negative 10 and the 2n, coupling the 2n with the 4n squared. So 4n squared plus 2n minus 10n minus 5 equal to 0. So let's group it. So I can pull a 2n out of the first. That would give me n plus 1. So 2n plus 1. Then I'll have, if I have a 2n plus 1 as one of my factors, it also has to be on the other side. So I need to have a 2n plus 1 over here. I'm going to have to factor a plus 5 out. No, a negative 5 out, because this one has a negative sign, this has a plus sign, so to get the signs to switch, a negative is going to have to be factored out. So that would be minus 5. Okay, so I'm going to have 2n minus 5. 2n plus 1 equal to 0. So my zeros will be what makes this part go to 0. 2n minus 5 equal to 0. So this n is 5 halves. This n would be equal to a negative 1 half. So those are my two zeros. Now I'm going to solve it by the quadratic formula. I better get the same answer. So first thing, is this thing set up with a 0 on one side? It is. So A is equal to 4. B is a negative 8. C is a negative 5. Using the quadratic formula, x is equal to a minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and plug the numbers in. X is equal to a minus b minus a negative 8 plus or minus b squared. B is a negative 8, so that's a negative 8 squared, minus 4 times a times c all over 2a. X is equal to 8 plus or minus the square root of 64. This is going to be a minus 5 times 4. That's a negative 20. A negative 20 times 4 is a negative 80, so it's a negative 64 minus a negative 80 all over 2a, and a is 4, so that would be 8. 8 plus or minus the square root of 64 plus 80 is 144 all over 8. The square root of 144 is 12. 8 plus or minus 12 all over 8. So now I'm going to have two answers. One of the answers is going to be n is equal to 8 plus 12. That would be 20 all over 8, which is going to be equal to, divide the 20 by 4, 5 halves. The next solution, I will take 8 minus 12. That's a negative 4. all over 8. That's a negative 1/2. So my solutions are 5/2 and a negative 1/2. Okay, the next one is going to be completing the square. I better get the same answers. So on completing the square, the first thing to do is if there was a number right here, we could go ahead and move the 5 over or move the number over with the 5. But so probably what I'd do first is make sure it's set up in standard form like this. Now I have 4n squared minus 8n minus 5 equal to 0. Now when we do completing the square, we never do it with a coefficient other than 1 in front of the n squared. So what I have to do is get rid of that 4. So I'll simply divide everything by 4. And that changes my equation to n squared minus 2n minus 5/4 is equal to 0. Now the next step is to move this 5/4 over by adding 5/4 to both sides. And that'll give me room to complete the square. So now then, what I have to do is I take a look at this middle term, and I need to have something I'm going to add. It'll always be positive what I add because I'm going to square half of this middle term. So half of the middle term, so if I have a negative 2, half of that would be a negative 1. And then I'm going to square a negative 1, so I'm going to add 1 to the left-hand side, so I have to add 1 to the right-hand side also. So now that I've actually got a perfect square on the left-hand side, I can write it as a perfect square. So it'll be half of the negative 2, so that's n minus 1 squared. And what I need to do on the other side is I need to add those two numbers together. So 5/4 plus 1, and I need to give 1 a common denominator, so I'm going to make it 4 over 4, so I have 9/4. So really, what 5/4 plus 1 is, it's 9/4. Now I'm going to take the square root of both sides. So if I take the square root of n minus 1 squared is equal to plus or minus, you always add a plus or minus, the square root of 9 over the square root of 4. This is going to be n minus 1 on the left, and plus or minus 3/2 on the right. Now I'm simply going to add 1 to both sides, and the 1 will add before the plus or minus. So n is equal to 1 plus or minus 3/2. So I'm actually going to have to do that addition. And I'm going to, since this 3/2 has a denominator of 2, I'm just going to go ahead and change the 1 to a fraction with a denominator of 2 because it makes it easier for me. So now I have two solutions. I have n is equal to 2 plus 3 all over 2, 5/2. And the other one is n is equal to 2 minus 3. That would be a negative 1. Of course, they have the same denominator, so the denominator will be 2. That's a negative 1/2. So once again, I have the same zeros. Okay, the next one, we're going to graph this, and you could graph it and see the solutions. We can't do that because we don't have a graphing calculator, so we're just going to go back and graph it. Now, the way I'm going to graph it, there's two ways with this form. We have standard form. That would be the form that it's in. Right here is standard form, and you'd find x is a minus b over 2a. I think an easier way, since I already have the zeros, I have 5 and a negative 1/2, I could use intercept form. So I'm going to think of this as actually being in what we had in problem number 1 is we had the 2n minus 5 and 2n plus 1. If I figured it was in factored form, then I could just plot the zeros. The zeros are 5/2. That would be 2 and 1/2. And a negative 1/2. Okay, so now what I have to do is I have to plot the vertex. That's halfway between the two. This is a little more difficult than a lot of the ones we've done where we counted. So to find out what's in between there, I'm going to have to average my zeros together. So what I'm going to do is I'm going to average 5/2 and 1/2 together. So that would be 5/2 minus 1/2, and then whenever I'm done with that, I would take it by 1/2. The same thing as dividing it by 2. So 5/2 minus 1/2, because that's the same thing as 5 halves plus 1/2. I would get 4 halves times 1/2. Okay, so that's going to be equal to 4 times 1 is 4. 2 times 2 is 4. So I get 1. So 1 is right in between those two zeros. That's my axis of symmetry. X equal to 1. So now then to find the vertex, I simply plug 1 into the equation. So I could plug 1 into this equation. I would get 4 times 1 squared minus 8 times 1 minus 5 equal to y. Now it's not equal to 0. I'm trying to find the y value of the vertex. So that would be 1 squared is 4. That's 4. Minus 8 times 1 is 12. Minus 5. That would be 4 minus 12. That's a negative 8 minus 5. That's a negative 13. So my vertex is 1, negative 13. Okay, actually, 8 times 1 is 8. So I'm going to change this. That's going to be 4 minus 8 minus 5. So 4 minus 8 is a negative 4. Minus 5 is a negative 9. So when I plug 1 into the equation, which I know is the y value of my vertex, I get negative 9 coming out. So 1, negative 9 is my vertex. And this parabola would look like this. Okay, so for these, I'm going to solve them in the fastest way. The first one is already factored for me. To multiply them together and then do a different method would be kind of stupid. So I'm going to go ahead and just find what would make this factor go to 0. That would be 7n minus 6 equal to 0. Move the 6 over and then divide by 7. So n is equal to 7/6. That would be 6/7. And then the other 0 would be n is equal to a negative 4. Moving over to number 6, you could use a quadratic formula on any of these. Most of you would choose to use, you could use completing the square. Most of you would probably choose not to complete the square. You'd probably prefer to use the quadratic formula. But factoring would be quicker if I could factor it. Looking for two numbers that add to a negative 4, multiply to a negative 32. Well, that would be a negative 8 and a positive 4. So factoring this would be the quickest way to find the zeros. V is equal to 8. V is a negative 4. Moving to the next one. This one, I could solve this one of several ways. I'm going to go ahead and factor a 7 out. I know on this one, what I'm going to do is I'm going to factor, if you notice that there is a 7 and an x that can come out of that. So if I first take all my common factors out, I'm going to get 7x times x plus 7. And so now this is ready to go ahead and find the zeros. For this x right here, the value that I need for that to put a 0 on the other side would be x equal to 0. And for the factor that's in parentheses, x is a negative 7. Okay, the next one I could use the quadratic formula on. I could use try AC middle, so I'm just going to try AC middle. That would be quicker than the quadratic formula if it does factor. So let's quickly see if it would. So AC would be equal to 28. The middle is equal to 11. Looking for two numbers that multiply to 28. Add to 11. That's going to be 7 and 4. So I'll go ahead and use AC middle on this one. So that would be replacing the 11b with the 7b and the 4b. I get 7b squared plus 7b plus 4b plus 4 equal to 0. Factoring a 7b out of the first half, I get b plus 1. That means I need to have a b plus 1 on the other part. And that would have to have a 4 factored out, a plus 4. So 7b plus 4 times b plus 1 equal to 0. B is equal to a negative 4/7. B is equal to a negative 1. That's a 7. Moving on to the next one. I'm going to see if I can use AC middle on that. That means this number here needs to move to this side by subtracting 4 from both sides. 3m squared minus 15m minus 18 equal to 0. So 3 times 18 is 54. So AC is equal to a negative 54. The middle is equal to a negative 15. So I'm looking for two numbers that multiply to a negative 54 and add to a negative 15. That would be 9 and 5. So I have, no. Okay, so the two numbers that I would pick is it can't not be a negative 9 and a negative 6. Those would add to a negative 15, but they would multiply to a positive 18. Those don't work. What does work is a negative 18 and 3. Okay, so I'm going to go ahead and pull out the negative 15. So I have 3m squared plus 3m. Now I'm going to subtract 18m because those are m's. Minus 18 equal to 0. Group it. 3m times m plus 1 minus 18 times m plus 1 equal to 0. So I have 3m minus 18 times m plus 1 equal to 0. So over here, the m is going to be equal to 18/3 is equal to 6. M is equal to a negative 1. Let's go work some of the others in the time that we have. Okay, 12. Okay, what I'm going to do for number 12 is I'm going to go ahead and bring the 100 over. And now I'll look at it. There are two ways I could work this. I could work it because this is a perfect square and this is a perfect square. That's a difference of squares. So the square root of 81 is 9x minus 10 over 9x plus 10 equal to 0. So x is equal to 10/9. X is equal to a negative 10/9. That's one way I could have worked it. Another way I could have worked it is I could have simply said x squared and divide both sides by 81. Got 100 over here. Then take the square root of both sides. So I would have had x is equal to plus or minus the square root of 100 all over 81. So x would be equal to plus or minus the square root of 100 is 10. The square root of 100 is 9. So I could have worked it by square rooting both sides. Let's move over to number 11. This one would be the square root of both sides. So what I'm going to do is I'm going to say, okay, x plus 4. Take the square root of x plus 4 squared. Then put the other side, take the square root of a plus or minus negative 49. The square root of x plus 4 squared is x plus 4. The square root of a negative 49, this comes out as an I, is equal to plus or minus 7i. Now I'm going to subtract 4 from both sides. So I got x is equal to a negative 4 plus or minus 7i. Okay, and moving to the last problem of those that's on this page. Okay, for this one, I'm going to move the 7 over by subtracting 7 from both sides. and that's going to give me 3p squared minus 11p. Subtract 7, I get minus 8 equal to 0. And let's work this one a little different. We could probably try AC middle, but let's make sure that we have one with the quadratic formula. A minus b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal, a here would be equal to 3, b is equal to minus 11, c is equal to 15. Oh, no, c is equal to 8, negative 8, because I had to move it over. Positive 8. Sorry, let's adjust. Subtract the negative 7, that's a plus 8. So c is equal to 8. So let's go ahead and plug the numbers in. So I have x is equal to a negative b, that's minus a negative 11, plus or minus the square root of b squared, so that would be a negative 11 squared, minus 4 times a times c, all over 2 times a. X is equal to 11 plus or minus the square root of 121 96 all over 6. It's equal to 11 plus or minus okay, so what I did is I went ahead and worked it out, got 11 plus or minus the square root of 25 over 6. The square root of 25 is 5. So I have 11 plus 5, that's 16 over 6, that's 8 over 3. And then I have one side of it, which is 11 minus 6, 11 minus 5, which is 6 over 6 is equal to 1. Just do what I want you to do. There, okay, it's going. Okay, so on this one, number 13, this is simply an adding or subtracting complex numbers. So we have a negative 2i. Computer's kind of sluggish at the moment. Negative 2i minus 6. This negative distributes in minus 8. Negative distributes in minus 5i. Okay, so now what's going to happen is the negative 2i, the negative 5i are going to combine. The negative 6 minus 8 is going to be a minus 14, but it talks about standard form. That means you have to put the real number first, so it should look like that. The next one is also a subtraction. There's no multiplication involved. It's going to be a negative 7 plus 4i. Now I'm going to distribute that negative in. That's going to be plus 5. Distribute the negative to the other term, minus 5i. So this time, so I don't have to write another step, I'm going to do the numbers first. So negative 7 plus 5, that's going to be a negative 2. I've got a 4i minus 5i, so that's going to be minus 1i, and that is already in standard form. The next one is a multiplication, so I'm going to use FOIL. I have a negative 1 times 5, that's a negative 5. Negative 1 times a negative 8, that's plus 8i. I have 7i times 5, that's plus 35i. And 7i times a negative 8i, so 7 times a negative 8, that's a negative 56. I times I is I squared. Now I squared is a negative 1, so negative 1 on this 56 will change this to a plus 56. I have a negative 5 at the front, and I have 8i plus 35i. It's going to be 43i. Now then, taking the negative 5 and combining it with the negative 56, I would get 51, because the real number comes first, plus 43i. Okay, so the problem here that says simplify, it has an I in the denominator. We cannot have any imaginary numbers in the denominator. So I'm going to need to multiply this by the complex conjugate of the denominator. So if this denominator is 6 plus I, I'm going to multiply both the numerator and the denominator by 6 minus I. Now I'm going to enclose them in parentheses so I don't get mixed up on the FOIL method. So what this is going to be, the numerator will be a negative 3 times 6. That's a negative 18. A negative 3 times I, that's going to be a plus 3I because I have a negative times a negative. A 5I times 6, that would be plus 30I. And a 5I times a negative I would be a negative 5I squared. So that's my numerator. The denominator is going to be 6 times 6 is 36. 6 times a minus I is a negative 6I plus I times 6 would be plus 6I. And lastly, I times a negative I is a minus I squared. So let's go ahead and simplify some of this. The numerator is going to have a negative 18. Then I have 3I plus 30I. That would be plus 33I. And then the minus 5I squared. I squared is a negative 1, so it's going to flip the sign in front of the 5. On the denominator, I have 36. Now I have a minus 6I and a plus 6I. Those will go away. Minus I squared. I squared is a negative 1, so that will change that because it's a negative of a negative 1 to a plus 1. So continuing on, I'm going to have the negative 18 and the 5 will combine. That would be a negative 13 on the numerator plus 33I. And my denominator will be 37. And I'm going to go ahead and split those up into the real portion and the imaginary portion. So what that'll be is a negative 13 all over 37 plus 33I all over 37. And can I reduce anything? No, the 37 is not going to be able to reduce. So that would be my answer. Okay, moving on to the next ones, I need to find something that's going to give me a perfect square. So I look at the middle term, and I take half of that. So a negative 12. So what I'm going to have is I'm going to take a negative 6, and I'm going to square it. So that's going to give me plus 36. So the value of C that makes it a perfect square is 36, and I have to write it as a perfect square. So that would simply be half the middle term, so negative 12 minus 6 squared. On the other one, I've got 3. Now I need to take half of that, so that's 3 halves, and I'll square that. And that's going to be 9/4. So I'm adding 9/4. That's what I need to add to make it a perfect square. Then writing it as a perfect square will simply be half the 3. So plus 3 halves squared. The last part is the discriminant. The discriminant is simply b squared minus 4ac. It does not include anything else in the quadratic formula. So it's just b squared minus 4ac. So for the problem that I have, it's already got everything on one side and 0 on the other, standard form. So a is 9, b is a minus 6, c is 3. Plugging it in, b squared, negative 6 squared, minus 4 times a times c. So I have 36 minus 36 times 3. 108. Looks like I get a negative 72. I hope that math is right. So negative 72. So anyway, it's going to be negative. Negative means I'm going to have 2 imaginary zeros. Okay, so the two things that I needed is I needed to find the discriminant and I needed to state the number and type of solutions. Is going to be, okay, this is already in standard form. So what we have is we have b squared, and no, let's the a is 9, b is a minus 6, c is 1. So for this one, b squared minus 4ac, that would be a negative 6 squared minus 4 times a times c. So that's going to be equal to 36 minus 36. So I have a 0 for the discriminant. If the discriminant is 0, I have one real solution. So two answers. And we're done.